presume you all can see that okay. Let me open up the various chat windows and things on my other screen. I don't know how to make my presentation full screen offhand, but that's okay. All right, so welcome everyone to orientation session A of we actually have a two-part orientation. We have a session A and a session B. Lately, we're running each of these once a month. They do have different content, so we're running session A today, and then we'll run it again in a month, and session B will be offered in 2 weeks. So if you're interested in the session B, which I recommend you check out, come back to this time slot in 2 weeks. Session A is really an overview of N3C in general, sort of the organization of N3C, the various teams. It provides a high-level overview of the data so that you can sort of decide whether or not this data sounds like it's of interest to you if you're not yet into N3C and not sure if it's a good match for you. Session B is a lot more technically oriented, so it provides sort of like a whirlwind tour through all of the technical details of how to work with data and analysis and the tooling that we have built inside of the enclave. So both are very useful. Session B is definitely useful for the data scientists in the crowd, whereas I think the session A is useful for pretty much everyone. Make sure here. I'm just sort of allowing our recent joinees to talk. As I mentioned, I'll be pausing for questions here or there as I go, but we do have a fair amount of material to cover, so I better continue on with it. So one thing you'll figure out about N3C, if you haven't already, is that knowledge in N3C is really distributed. You know, we have a lot of different experts from a lot of different fields that are contributing to make this whole experiment work. And this orientation itself wouldn't really have been possible at all without the input of the experts that are listed here from some of the various teams and things that we have going on in N3C. Sean O'Neill is myself. I'm listed as Oregon State University, although our lab just recently moved to Colorado University at the Anschutz Medical Campus. So I should probably update that in this particular presentation. So let's talk about the problem that N3C is addressing, which is, that the US has no central data repository. In fact, we don't really even have a standard data model or format. Different organizations use different systems. Each organization generally has its own quote unquote data warehouse for internal use, whether that be billing or whatever it is. And these are often quite unique to the organization, hospital, healthcare system, or whatever it is. Some progress has been made, however, by research consortia, mostly built of researchers who want to do research on electronic health medical records sourced from different institutions, which is quite different if everybody has a different data model and data format. What they've done is they've put together what are known as common data models, or CDMs. And these are sort of agreed upon methods of data organization, right? These are often secondary data sets generated from the original electronic medical records in the data warehouse. But basically the idea is that if, institutions A, B, and C want to participate in some electronic health research, then they agree on a way to store and model their data so that researchers who want to work with that data have a common format of it across some of the different institutions participating in that particular research network. And this is what's primarily up till now been known as a federated model. So researchers, for the most part, who want to access, I2, B2 formatted data from around the country would generally identify or associate with one of those particular research networks or partner institutions. And then they'd identify a question that can be asked against that sort of like data format, data model. And then they distribute their query to the data partners. And then the data partners would run their query on their data sets locally and then sort of ship the results back to that researcher. So the researcher doesn't have direct access to the data. Rather, they sort of assume that the data are in a common format in these different locales. They send off their query, it gets run, and then the results sort of get shipped back. And that particular federated model has sort of been a way around the various data sharing issues that happen in the United States. but it doesn't really give direct access to the data set. And so it precludes kind of like exploratory analyses, comparative analyses, as well as certain machine learning techniques and things like that, which really work best when you have direct access to all of the data at one time. So what N3C is doing is that we are recruiting data partners from around the country who participate in some of these federated models. And then we're collecting COVID-related data from those common data models into a single unified database and model, and this is known as OMOP. This is tricky because these source common data models are quite different, even though they've already, somewhat harmonized the data into either an I2B or a PCORNet or an ACT or whatever data model. Those data models themselves can be quite different. And so we have to deal with the intricacies of very diverse data being harmonized into a single data set. And there's actually a team of wonderful N3C people who work very closely with our data partners to help them develop the scripts and the various other bits that are needed to get their data shipped over. And then we have an internal team which works on the harmonization so that the data gets cleaned up as best as it possibly can be to go into this centralized data set. The target data format or model is known as OMOP, and we'll hear a lot about that. It's a big deal in N3C because that is our primary storage format for our data. It's also one of the common data models that's used by some of the data partners. So it has this nice feature that it's possible to ingest various different data models into this particular common data model, and that's why it's been chosen by N3C, and we'll hear a little bit more about it in a bit. But if you're not already familiar with OMOP, this can be a learning curve that you might have to get over as you start working with the data in N3C. But fortunately, we do have a lot of training resources and other information available to help you work with OMOP formatted data. Because this is sensitive data, we can't redistribute it out to researchers. Rather, what we do is we keep it under lock and key in a highly secure cloud enclave, we call it. To which access is granted to research teams with fairly comprehensive access controls because there is HIPAA protected information stored in this particular database. And this can be another learning curve for folks because there are several steps involved with getting access to the data. And then finally, the interface that we deal with, because this data has to live in the cloud, is a little bit different than you might be familiar with. So if you're familiar with RStudio or Jupyter Notebooks or something like that, we don't have those particular tools because we need to track sort of from start to finish everything that happens with the data inside of this enclave, and those tools aren't really built for doing that kind of tracking. Nevertheless, we do have some access to some really cool tools inside of the enclave, and there is support for your favorite data science tools. I hope particularly Python, R, and SQL, and a whole bunch of libraries for those particular languages, as well as some really cool graphical user interfaces for data analysis that we'll see some screenshots of here in a moment. So what's actually in the data? This is a screenshot of the dashboard. It's already a little bit out of date. We've got more data in there right now. But at least as of this particular screenshot, there were 60 data partners who were contributing data on almost 6 million patients, and about 1.2 million of those were COVID positive. Now notice there's a little bit of a star here, and that's because we're defining COVID positive for this particular count in a particular way. So what we have represented in the data are sort of the raw after harmonization electronic health records. So we know lab tests that were involved in the electronic health records, and we have sort of diagnosis codes and stuff like that. So this particular star is counting up everybody who's had at least one positive result for either a PCR or an antigen or an antibody lab test, or a diagnosis code of UO7.1, which is the ICD-10 code for COVID-19 diagnosis. So those are our COVID positive cohort. And what we do is we ask the data partners to identify all the individuals at their particular site who match that particular definition. And then we also ask them to look at those and identify twice as many quote unquote control patients, demographically matched on basic stuff like age and sex and gender and race. And you'll notice here all of a sudden that I'm already a little bit off. So we've said that the data consists of folks who are COVID positive plus twice as many quote unquote control patients, but these numbers don't match that. Um, Actually, as of now, they're much more closely matching. But the reason that they don't match it in this particular screenshot is that we've changed this definition of the information that our data partners contribute over time as the pandemic has evolved. So it used to be that we would ask our data partners to provide data on all patients that had a COVID test, whether or not that test resulted in COVID positive or COVID negative. Earlier on in the pandemic, that was a sensible thing to do. However, as the pandemic progressed and more people were getting tested, but coming back ideally negative, we found that we were collecting information on basically every patient at our data partners, which was never really the goal. The goal of N3C is to be the National COVID Cohort Collaborative. So all of our efforts are centered around COVID, and we were simply slurping up more data than necessary. So we changed the definition of the data that we would request our data partners send us. And this is known as the phenotype version, quote unquote. And so the latest phenotype version uses this 2-to-1 matched control definition. But as of this particular screenshot, not all of our data partners had updated to that particular phenotype version. I mention all of this not necessarily so that you worry about exactly what's in here at this particular level, but I do want to mention that the data that is in N3C is really dynamic. It does change over time. It changes over time as we update that phenotype definition and we change sort of what we're requesting our data partners provide. And it changes as well, of course, as we get new data partners online to provide more data and so on and so forth. I've put controls here in quotes because, of course, this isn't really like a random sample or anything of the population. That's something you're going to want to keep in mind as you're analyzing this data. These are sort of data that have been identified with data partners that we've partnered with, which are not equally geographically distributed and so on and so forth. With all that said, that's what's currently in the data, or at least that's what was in the data as of this particular screenshot. But that's for basically the release that this screenshot is about. Every couple of weeks or every week, there is a new release of the data. And if you ever need to, you can always go back in time and say, okay, what was the release as of 4 months ago? So you can go and look at the snapshot of the data as it was at a particular point in N3C's history. For the most part, you'll want to work with the current release because it has the most comprehensive and the highest quality data. But when it gets close to sort of publication time or something like that, you might want to pin to a particular release so that your results aren't changing underneath of you as you're trying to write your paper or whatever it is. We don't grab all electronic health records for these particular individuals. Rather, we collect all electronic health records going back to January 1st, 2018. So we have a few years of history, but not the entire patient history as represented by their health records. And that's not too much of an issue, but you can get into situations where if there's something in the patient's record that was 5 years ago, maybe they got diagnosed with MS or something like that, but it's well controlled and it was never mentioned in their electronic health record subsequent to that, you may not know about that particular event for that particular patient because not everything is revisited in a person's electronic health record as time goes on. Down here in the second row of this table, this is just showing some of the detailed row counts for the actual tables storing some of the data that are in that OMOP schema that I mentioned. And you can see that we just have lots of really good, yummy data to analyze in N3C. Okay, that's not even yet the entire story though. We have some more information about the kind of data that we have available. In fact, what we've done is we've split the data out into 3 different levels of data. Actually, it's not really a split, they're different representations of the same database in 3 different levels. The rawest form of the data that we can make available are what we call our level 3 or limited data set. And these are basically patient data that do have 2 protected health information fields as defined by HIPAA. They contain accurate dates of service and full patient zip codes. And because this level of data does contain those 2 HIPAA protected fields, we have different sort of access levels and access requirements for the level 3 data. I have a small caveat that this is a new addition to this particular thing because we've decided that it's something we should highlight up front, which is a tiny little caveat here, which is that most of our data partners do provide us with those accurate dates of service for this level 3 data set. We do, however, have a few data partners who do a little bit of pre-shifting of their dates that actually makes it look a little bit more like the level 2 data that I'm going to talk about in a quick minute. I'm going to mention this more later when it makes more sense, but I just wanted to mention it right here that not every data partner provides full accurate dates of service, and we'll talk about how you can filter out the ones that don't provide that if you have access to level 3 data. The level 2 data remove those 2 protected health information checks from the level 3 data, and so we call it the de-identified data set. Specifically, what N3C does is it takes the dates of service and it algorithmically shifts them. It randomly shifts dates of service to protect patient privacy, and patient zip codes are truncated to the first 3 digits. And that makes this particular data set no longer containing any of the 18 fields defined as protected health information by HIPAA, and we can give different access requirements and restrictions to this particular level 2 or de-identified data set. If the idea of randomly shifting dates of service makes it sound like this data set is completely useless, don't worry just that much, because it turns out that this is done on a per patient date basis. So for a particular patient, all of their dates will be shifted by the same random amount. So you'll still be able to go into this data set and say, okay, I need to find everybody who had a positive COVID PCR test and then within 10 days got a particular drug. You can do that in the level 2 data set. You just don't know exactly when that happened or where that happened. The level 1 data set is actually not in an OMOP format, and it's what we call the synthetic data. And these are data that are computationally derived from the level 3 data, and they're actually derived from a statistical model of the level 3 data. So the way this works is you say, okay, I'm interested in BMI, diagnoses of diabetes, and 6 other relevant things from the level 3 data. Someone goes in and builds a fairly cool, as I understand it, statistical model based on that information from the level 3 data, and then synthesizes some data for the level 1 that you then get access to. And the idea here is that this data set is not, doesn't contain any real data at all, but is similar enough in the parameters that are specified that you can do real research with it. There's of course always a question as whether or not you're going to get the same result out of a synthetic data set as you would get out of a limited data set. And fortunately, we do have a team of folks who are working on that exact question of, validating synthetic results and comparing them to the results that you get from the level 3 data. And the results are pretty good. Things match up pretty well, provided you stay within the realm of the parameters that you requested for the synthesization process. So there's a little bit of a process involved in generating this and getting access to it. So on to access requirements for these. Level 3 data is available to researchers from US-based research institutions. Level 2 data is additionally available to researchers from qualifying foreign research institutions. And this level 1 data is available to pretty much everybody. You don't have to be affiliated with a research institution to get access to the level 1 data inside of N3C, and we call these folks citizen scientists. How you actually get access to these data, as I mentioned earlier, is a little bit complicated. To get access even to just the level 1 data set, there are sort of like 3 main steps. The first one is that you got to get registered with N3C, which means sort of like logging in and creating an account. And then the second step is you actually need to get access to the data enclave with that account. In order to do that, we have to verify that you've been covered by what's known as a data use agreement, which is a legal document which covers sort of your behavior and the consequences for it. And we're going to talk about that in a moment, but that's a prereq in order to get your account sort of enabled to log into the enclave. Once you're able to access the enclave, you still don't get access to the level 1 data. In order to get access to the actual protected level 1, level 2, or level 3 data, you have to fill out what's known as a data use request, and that happens inside of the enclave, which is like a form that you fill out where you say what you want access to and you justify why you want access to it, and you say, yes, I've done X, Y, and Z kind of trainings. One of the trainings involved in the level 1 data access is an NIH security IT training, essentially, and there's a link to it that you can access. It's like 90 minutes. And you can read more about all this information on this link down here, N3C governance. Once you've gotten access to the enclave, getting access to the level 2 data is very similar to getting access to the level 3 data, except you also need to have completed human subjects research protection training, which is often offered by research institutions, via the CITY program or something like that. If you don't have access to the CITY program or something like that via your institution, there are options for you that we can provide, but it's important to check with your institution to see if they provide this human subjects research protection training. That way you're following your institution's policies. And so you'll have to have completed that. It's quite a long training, depending where you're at. It can be up to 8 hours. And you want to have the completion date of it handy so that you can complete this DUR inside of the enclave to request access to level 2 data. Level 3 data have all the same stuff, except you also need to have an institutional research protection program IRB board take a look at your project and determine whether or not it's appropriate or not, and produce a letter of determination, which you can also then upload as part of that data use request process to get access to the level 3 data. We're not going to talk a whole lot about this level 1 synthetic custom data in this particular orientation, but mostly focus on the level 2 and the level 3 data. Nevertheless, before we sort of forget about it altogether, I want to give a little bit more information about it. So as I mentioned, what the process looks like is you sort of get approved through this process to access level 1 custom synthetic data. And then what you can do is you actually, inside of the enclave, you can make a request to have a synthetic data set generated for your research project of interest. So as I said, okay, I'm interested in BMI and diabetes and COVID infection or something like that. And then you can make a request and somebody, I think we call them synthetic data liaison, no, synthetic liaisons or something of that nature, who will help you generate that particular data set from the statistical model for level 3 data. And so every project might actually have a slightly different level 1 custom synthetic data set generated for it based on those questions. But when you get access to the level 1 data, you actually get access to all generated level 1 data sets. So you'll see all the different ones that have been generated for both your project and any other projects that other people may have requested. And there are some somewhat quote unquote generic synthetic data sets with common variables in them that you can play around with as well. This is what an example of a synthetic data table looks like inside of the enclave. And you can see that this is basically just a single table. It's been pre-processed and pre-analyzed to contain the information of interest, sort of like who the source data partner was, what the lab test category is, information about median household income in the region of the person where that person was from, information that's been otherwise linked in, and so on and so forth. So as I said, the level 1 synthetic data is not in an OMOP format, which is a multi-table format, but rather in a custom format, which is a single pre-processed data table format. I do have a big no screenshots symbol here, and that's because in general, it is a no-no to take screenshots or screen share anything from inside of the enclave that is protected by a level 1, level 2, or level 3 DUR, and that includes this synthetic data. I've got some very special permission for this particular orientation to show it to you guys right now. As I mentioned, these level 1 synthetic data sets are generated on a per question basis, and so they also come with release notes which describe which variables went into that statistical model to generate the synthetic data, and you can read about those in the same folders right next to the data. And the generation of these data, this synthetic model, as it were, is actually produced by a private company known as MD Clone. And our MD Clone partners have been kind enough to provide us with some links here. I'll put the links to the slides in the chat so that you have all these links before we go here today. All right, so I'm going to take a real brief pause and see if anyone has any questions. If you do, feel free to use the little like raise hand feature in Zoom and do a quick call on you. Otherwise, we'll continue moving on.
Yes, I have two questions, please. Hello?
Looks like someone's calling in on the phone and might be attempting to talk, but I can't hear you.
Yes. Do you hear me? I have two questions.
I can hear you now. Yeah, go ahead.
First of all, this is Nasser El Baathi from Auckland University. My first question is about imaging data. My understanding, imaging data is not available. Is that true? And if it is not available, is it going to be available sometime and when? This is my first question.
It's a little coming through a little muddy from the phone, I think. Can you repeat what specific data you're interested in?
Yes, I'm asking about imaging data. Is it available?
Aging data?
Imaging data.
Imaging. We do not have
Yes.
imaging data available yet, but there is a large effort within N3C right now to be able to link data. So, primarily our data are the electronic health records, not imaging, not oxygen flow rates, not genetic information, so on and so forth. But there's a lot of interest in making that happen. Part of the issue is that we need to be able to say that this particular record from this data source is from the same individual person as that record from a different data source without actually revealing who that patient is, right? We don't want to be able to say that people are the same people without saying who they are. So there's quite a lot of infrastructure required to make those data linkages in a protected, patient protecting manner within the system. So there's a large effort going on right now and is actually just gearing up to get started. So I think that we might get there maybe before the end of the year, fingers crossed, but we don't have imaging data in there yet that is linkable.
Okay, my second question is about you mentioned that the data will not be directly accessible by the investigators, and we have to basically submit a data request form in order to get our data. So we basically in this form we should write a query for the data that we are interested in.
I'm assuming you're talking about like the level 2 or the level 3 data. Once you fill out, so all the data lives in the cloud. So it's everything that you do is going to be accessed via the browser, and you have to use cloud-based tools to work with the data. Once you've filled out the DUR form and it's been approved, you have access to browse all 6 billion rows of data should you want to. And then we have some tools that'll help you, Python, R, and some graphical tools that'll help you do the data analysis yourself. So you do get direct access to the data, but it's mediated by your web browser, and you won't be able to download any data to your local machine, except for when it comes time for publication. And even then, we'll talk about it a little bit, but even then you're going to need to have anything that you do want to sort of export from the enclave reviewed by someone so that they can verify that there's no patient details leaked.
Okay, thank you.
Khalid, I think it looks like you have a question.
Yes, my question is, do we have some clinical notes available if imaging is not there?
There are no direct clinical notes that I'm aware of. There is a team of folks who are working on essentially analyzing the clinical notes and doing some natural language processing on them, and then sort of generating more structured data from that. So there's a natural language processing team. And I'll show you later how you can actually sort of find out who those folks are and get engaged with that if you're interested in it. But right now, as I'm aware, that it's not, clinical notes are not generally available.
Yeah, a follow-up question is, when we are looking at the projects, there are a lot of projects which are talking about using, medical imaging and even natural language processing. That how we also got interested in this data set as well. So the project listed there are essentially, um, not conveying that definitely data is available.
Yeah, if there's a project, I know that there's teams who are interested in imaging, and I know that, but I don't know if they're working on existing imaging data in the enclave. I think maybe the best I can say at this point is that if you wanted to reach out via our office hours or offline or email or Slack or something like that, we can do a little hunting for you and figure out the best place for you to get plugged into what you're interested in.
Thank you.
Yeah.
One more question, please. Once again, this is Nasser El-Basri.
Can you say that again?
Yeah, I have one more question about how soon the data that we request will be available and delivered to the investigators.
Imaging data?
No, the data that we will request. How soon it will be available
Oh,
once we submit the request?
it takes about, it can take like about a week to get access to the enclave, depending on which institution you're from. And then once in the enclave and you do the data use request process, it can take up to 2 weeks to get access to the data itself. So it can take a few weeks to sort of go from 0 to data access.
So you say that depending on the institution. So I mainly from Auckland University. So as Auckland University investigators, do you know how soon it would be available? 2 weeks or
That
even maybe more?
that's that's the next topic that we'll go into, to get access to the enclave and what's involved. Yeah, so I think you'll get that one answered in just a minute. And then once you're inside of the
Thank you.
enclave, it can take, like I said, up to 2 weeks, because every data use request is evaluated by a committee.
Thank you.
Yep. B. Jamerson asks, is genetic data available? And the answer to that one is no, not yet. Same answer as for the imaging data. There's a team working on making those linkages, but right now there's no genetic data available that I'm aware of that can be directly linked to the EHR data. Khalid, did you have more questions? I see your hand is still up, but maybe just
Just a very short question. There is a call from National Science Foundation, and actually we were thinking that we'll write that we are planning to use N3C data for that purpose. So at the moment, there is no guarantee that imaging and genomics data will be available. Is my understanding correct?
I don't know. I think it might be preliminary to make a guarantee, but only just barely. What I think would be a good idea is to reach out to me separately or make use of some of the other Q&A features that I'm going to talk about later in this presentation, to find out what the status is of that and whether or not it would be a good idea to mention it in your proposal. We might be that far along the where it would help your proposal.
Thank you so much.
Yeah. Alice asks a question about the DUA. Alice, the short answer is a month is a long time, and I think I would submit a support ticket, and I'll mention how to do that later on in this particular presentation. All right. Okay. All right. Let's move on. We'll talk about a little bit about the DUA process. So the DUA is something that it's a legal document that you're covered by, and it's between you or a representative of you, like your research institution usually. And it sort of specifies, the rules of the road. Don't don't attempt to re-identify patients, don't share any data that you shouldn't be sharing. Everything going on inside the enclave is logged, more stuff like that. And of course, everything you do with this data inside the enclave should be for COVID research only. Um, many institutions actually sign this data use agreement on behalf of their employees. And so, for example, there's probably over 200 so far, and you can see the list of them at covid.cdth.org/DUAs. And so if you're curious about this for Oakland University, for example, you can go to this list and see if your organization is there and signed up. If it is, then the process of getting access to the enclave is a lot faster because you're already approved by this data use agreement process. And so you just have to get registered, and then your account should be linked for enclave access reasonably quickly, because that's what's required in order to get access to the enclave. If you're from an organization that hasn't already signed a data use agreement for everyone at their institution, we can provide a little bit of help there, but basically the short answer is that you're going to want to go to your research office or some similar office so that they can get in contact with the lawyers and folks at your institution who are going to want to make sure that everything is up and up when they sign the data use agreement with the NIH. If you're not from a research institution, so that you can't have your institution sign on behalf of everyone at the institution, this describes citizen scientists, individuals can sign as well. If you do this, basically it's a PDF form that you're going to email directly to NIH, and they'll sort of say, okay, you're all good to go. But doing it on your own makes you a citizen scientist. You're only going to be able to access the level 1 data, whereas in order to get access to the level 2 or the level 3 data, you're going to need to be signed up with a DUA, an institutional DUA, as we call it. So just to sort of summarize a little bit these various enclave and data access bits, in order to get access to the N3C data enclave, you need to get registered with N3C. And we're developing right now some pretty comprehensive training materials on how to do that, because there's several steps involved as usual. And then once you're registered, someone confirms that your registration is covered by a DUA, often by matching, sort of like the tail end of your email address. So I'm at oregonstate.edu. That's the account that I registered with. Somebody checked that oregonstate.edu has a DUA, and therefore I'm okay to log into the data enclave. Once you've been approved to log into the data enclave, you can log in, but you don't actually get access to level 1, level 2, or level 3 data sets. Rather, the way it works is that there are research projects in the enclave, and you can think of these as essentially folders with special permissions. And those folders are given access to the level 1, level 2, or level 3 data as configured by sort of an admin on the back end. And then in order for a particular individual to get access to a research project folder, they need to fill out what's known as a data use request, or DUR. So they fill out this form and they say, hey, I would like to access this particular research project. Or if they're the very first researcher who wants to start up a new research project, they say, hey, I would like to have this particular research project created. Here's the title, here's the abstract, here's all the other information required. And then that gets evaluated by the data access committee. And provided everything is on the up and up, and they're not requesting level 3 data when level 2 data would do the job just fine for their research project. The data access committee approves it. The research project space is created. It's linked into the particular data level that's been requested, and then that researcher is given access to that research project folder. Other researchers can then fill out the DUR to get access to the same research project, and so those folks can collaborate. But you can also, as a research, have filled out multiple DURs so that you can get access to different research projects. One thing you won't be able to do is you won't be able to take any data from one research project folder and then, copy it or move it or link it into another research project folder. That way, someone who has access to level 2 data and level 1 data or something like that can't share data to their colleagues when they shouldn't be able to. We do assume, though, that once you do get enclave access, and it can take a couple of weeks for this DUR process to go through, you'll want to start learning and playing with the system right away. So we do have a couple of learning data sets which are in that OMOP format, but not level 1 or level 2 data. And those do not require DUR to access. You can get access directly to them. One of them is known as SynPuF, Synthetic Public Use Files, and the other one is known as Cynthia. And even though they both have the SYN in their name, they shouldn't be confused with the level 1 synthetic data, because these other ones are notional data, fake data, but they're synthesized to be fake data. A couple of the rules of the road worth mentioning. We do have a user code of conduct, covers some of the same stuff as in the DUA, COVID research only, follow all laws and regulations, don't attempt to re-identify individuals, but also don't attempt to re-identify institutions. So don't say, oh, I think this particular data comes from, Johns Hopkins, someplace or other, or populations, stuff like that. No screenshots of data or results, and no recording video calls that do show data. You're okay to be on a video call with data shown if everyone on the call are approved and have access themselves to see that particular data. This most commonly happens for people who are all on the same project and they all have access to the same project folder. And so those people will get on the call to work together and they can share screenshots and stuff with each other. Not screenshots, they can share video calls with each other. But we don't prefer that people do screenshots or recording of video. As you get closer to the end, do publish as much as you can. Hopefully, we can make a dent in this COVID thing and do attribute N3C properly. We'll have a little bit more information about that in a minute. And if there is a data access incident, you notice that there's data being shown when it shouldn't be, or someone's gotten access when they shouldn't have, report that within 2 business days. And we also have a community guiding principles document, which talks about our values of partnership, inclusivity, transparency, reciprocity, accountability, and security. And there's also information on ethics, diversity, and inclusion, and a process about resolving issues through community arbitration, should there be anything that pops up. Once you get closer to publishing, if you've got a paper to submit, or you've got a drafted and ready to submit, or you've got a poster or an abstract accepted, you can get it reviewed by what's known as the publication committee. And they're basically going to make sure that your publication matches what you said you were going to do in the data use request, and that it doesn't accidentally leak any protected patient information. There's a rule about exporting of results, which basically say that there shouldn't be any cell sizes, whether you're talking about, like a summary table or a graphic or something like that, of between 1 and 19. So if you want to say that there were 21 individuals who had X, Y, or Z, or 20 individuals who had X, Y, or Z, that's okay. If you want to say that there were no individuals who had X, Y, Z, that's okay. But if you have a number between 1 and 19, then you should just say less than 20. Or between 1 and 19 or something like that, because those very small groups are considered more of a risk for re-identification. And there's some more details about this whole process that you can find at that link there. You may be curious to know, there've been a couple of questions about sort of imaging data and genomic data and genetic data. We don't have those, but we do have other external or supplemental data that can be linked to the primary EHR data. And this is stuff like from the census or publicly available data sets, FDA, stuff like that. Those data sets can be used alongside of the N3C level 1, 2, or 3 data, but before it can be uploaded into the enclave, it has to be reviewed for sort of security and license permissions and all that sort of stuff before we can bring it in and use it. And that happens via sort of like request and review process. Once a data set has gone through that request and review process, however, it's made available to everybody in the enclave. So you don't have to like re-request a common census data set. And I think right now we have like 25 or so of these external third-party publicly available data sets inside the enclave that you can use alongside with your results about stuff like census or food availability, things of that nature. So there's details on that sort of request and access process in this link right here. Is there, B. Jameson asks if there's a data dictionary that can be reviewed prior to requesting access. There is, and I'm going to link to it in just a moment here. So before we go too much further, if you haven't already seen it, this is what a screenshot of the N3C data enclave looks like. This is the home page that you see when you first log into the enclave. I'm not going to go over it in just a ton of detail here, but there are some things I want to point out here. One is the support and contact button. So if you need to get some help and you do have access to the enclave, this is a handy way to do this. One thing you'll find as you're working at N3C is we actually have 2 help systems. One lives outside of the enclave and one lives inside of the and they're both sort of like help desk tickety kinds of systems. The one that lives inside the enclave is necessary because if you have a question that pertains to the data itself, that question itself could very well leak protected health information, right? And so the question needs to live inside of the enclave. So you have a question about the data itself and sort of like a detailed, hey, what's going on with this data kind of scenario, or you have a question about an analysis of data, like, hey, my code's not working and I can't figure out why. That's best to actually submit inside of the enclave under the help and support link down here. However, if you have been trying to get access to the enclave and you can't, you're not going to ask that question inside of the enclave. So we have an external to the enclave help desk where you can submit questions, and that's linked over here, covid.cd2h.org/helpdesk. And if you ever get confused about, where should I ask which kind of question, the support and contact button is basically to clarify that particular question. But in summary, if the question is about the data or about its analysis in some details, then you should ask it inside the enclave. Pretty much everything else should be asked outside of the enclave at the covid.cd2h.org/helpdesk. And that goes for someone had asked about their DUA being stuck for about a month. You should go here to covid.cd2h.org/helpdesk or /support. They go to the same place and submit a ticket there, and someone will be able to look at it. Another important button here is the training material button. So we have a variety of good training materials inside of the enclave for your use to help you learn how to figure out how to use the enclave, how to figure out how to use the data, and so on and so forth. So definitely check that out, especially the training portal, which contains training materials specifically for N3C. So there's some training materials inside of this link, which are about the interface and the tooling, but then we also have a variety of bits and pieces that are specific to N3C and our needs, so check those out in the training portal. These top 3 buttons here talk about that data use request process that we talked about. We don't have time in this particular orientation to go over the entire data use request, but those buttons sort of help you find other existing projects that you might want to join under Explore projects. If you want to start up a new project, you can use the data use request button there. Or if you want to see, the status of your requests with the data access committee, then you can go to the My Projects dashboard. And then, of course, we've got various other bits that you can find by browsing around the interface. So you can browse the projects, folders, and files that you have access to via that link. And there's some analysis tools that are shown under the apps area here. So some screenshots, if you were to click on this projects and files thing, you would see the projects tab open by default, and you'll have a list of all the various project folders that exist inside of the enclave. You'll see some request access buttons in this particular view. You can ignore those. We can't get rid of them. They're built into the interface, but they don't work because they don't take you to the data use request process, which is required for N3C in order to get access to one of these research project folders. There's also the data catalog, which is in another tab of that same projects and files section. And these are basically collections of shortcuts to commonly used data files. So for example, once you have access to the level 2 data, rather than finding it in the project folder where it's sort of like where its home is, you can find it in the data catalog under the de-identified data catalog item. There's also like a SynPuff one for the or Cynthia one for those notional data sets. And I don't see the level 3 LDS one here because I don't have access to that particular data level with any of my projects. This is a brief screenshot of the Contour application, which is a really cool graphical user interface for data analysis. Although it is graphical and hardcore coders might be tempted to turn up their nose at it, there are a few good reasons to get familiar with this particular tool. For one thing, it knows how to efficiently work with 6 billion rows of data automatically. So as you're working in the enclave, you'll find that data set size is something that you might struggle with a little bit, especially if you're used to coding in Python or R, but haven't worked with data sets of 6 billion rows. Everything in the enclave is backed by Apache Spark, which is a high-performance distributed computing framework. And as you're doing coding in some of the more coding-oriented applications, you might find that you need to work with Apache Spark or learn a little bit of the PySpark library or RSpark library, or get familiar with Spark SQL, which is the SQL dialect, which is available inside of the enclave, in order to be efficient and work with that amount of data. The cool thing about this particular app, this Contour app, is it's built on top of Apache Spark, and so it knows how to work with all that data, and you don't really have to worry about it so much. It can do pretty much everything that SQL can do, so it's great for data munging, joining tables, splitting tables out, filtering, gate arithmetic, all kinds of stuff like that. And then one of the nice things is that once you've done your sort of data munging and real basic visualizations in this tool, you can export the table so that you can load it up in Python or R or something like that, and work with a much smaller data set after it's been pre-filtered in a tool like this. And then you can use your normal, Python pandas or R data frames or whatever it is inside of a more coding-oriented interface. Speaking of a coding-oriented interface, this is Code Workbooks, which is sort of the code interface that's most commonly used inside of the Enclave. It's not quite Jupyter Notebooks, it's not quite RStudio, but it is a hybrid GUI interface for writing code. And essentially every node here represents either a data set, which is imported into the workbook, or potentially a function written in Python or R, which takes a couple of data frames as inputs and then spits out a table as output, or it could be SQL code as well. So you can actually mix R, Python, and SQL inside of the same analysis workbook, which is pretty cool. And then, of course, if you're doing visualizations, for example, in R or Python, this is the interface that you can have those shown in as well. There are like 5 other useful tools that we don't have time for in this orientation, but there's like a reports tool where you can embed tables and figures from other tools along with text, so that you don't have to send this particular interface to your PI. You can send them more of a structured report, and those are used for a couple other things inside the Enclave as well. There's a spreadsheet-like tool where you can sort of like hand create data sets via an Excel-like interface, and so on and so forth. Okay, any brief questions about the sort of like tooling available inside of the Enclave before we move on to talk about the OMOP data model? And that's where we're also going to talk about a data dictionary. Okay, with that said, we'll move on. I'm going a little slow today. We've got a lot to cover.
I have some questions, please, regarding data accessibility.
Go ahead.
Yeah, do you hear me, please?
Yeah, data accessibility, is that what you said?
Yes. First of all, I would like to know, as an investigator, should I submit my DUR myself, or it has to be submitted through my research institution?
The DUR ends up being submitted inside of the Enclave, so no, you don't have to submit it through your research institution unless you're accessing the level 3 data, in which case your IRB is going to need to have the details of your project and produce a letter of determination for you to submit inside of the Enclave for the DUR process.
Okay. Regarding the coding part of the project, my understanding is my code will be developed and written in the environment of Enclave.
Correct.
Right?
Yep.
So in this case, am I will be able to save my files on my computer hard drive, or it is not allowed for me to save any content, including my code, on my hard drive computer?
Any data or figures or summary tables that you want to export need to be reviewed, but you can do that and then sort of like download them. But that's really meant for publication level summary tables and graphics and stuff like that. Your code, there is a way to, I'm pretty sure there's a way to export it from the Enclave. I think like to GitHub or something like that. And so that's sort of certainly possible for reproducibility. There's a little bit of a caveat there in that it's not easy to get code from GitHub into the enclave. And additionally, when you export code from the enclave into GitHub or something like that, you'll get the Python code or the R code or whatever it is, but it's going to come with sort of a project structure and some enclave specific libraries that are required to make that code work in the enclave. And so you won't be able to take the code and easily export it from the enclave and then run it on your laptop or something like that because you don't have all the tools that are available inside of the enclave. So it is possible to, sort of put your code out there in case your reviewers want to say, hey, we need to look at your analysis code or something of that nature. They'll be able to do that and look at the logic, but it's not exactly the kind of situation where you could take your analysis code, export it, and then someone else could easily rerun it on their own data unless they have access to the enclave, where all those libraries and things that get included along with your code end up. Hope that answers the question. All right, so let's move on a little bit and talk about OMOP, which is the Observational Medical Outcomes Partnership. And in interest of time, I'm going to go a little bit fast through this, maybe. OMOP stands, Observational Medical Outcomes Partnership, which is actually a project from way back in 2013 that sort of meant to address the issue of interoperability in electronic health records in the United States, I believe. And the funding expired in 2013. And the most important thing that came out of OMOP, or at least in hindsight, was not necessarily the overall, all the things that that particular partnership did, but was the specific data model. The specific data model ended up being very useful. And since 2013, it's actually been stewarded by the Observational Health Data Sciences and Informatics Collaborative, which is an international collaborative who are taking on the charge of working with interoperable electronic health records, and they still maintain the OMOP data model, which is used by N3C. Observational Health Data Sciences and Informatics, or OHDSI, or pronounced Odyssey. OMOP is designed really to be organized data for analysis, not necessarily billing or other purposes. So if you're not familiar with OMOP, but you're familiar with other databases that are more useful for billing, it might be a little bit weird for you. The OMOP community in general, tries to take patient identity very seriously, and so they try not to include things like names and birth dates and all that stuff. But you do occasionally include some more detailed information like dates of service and zip codes that we have in our level 3 data. Most of the tables that are stored in an OMOP data set are person and event centric. So you'll have for each sort of row an identifier indicating which person that particular row is about, and a date indicating what the event was when it happened, and so on and so forth. I'm showing here a screenshot of the drug exposure table from the one of our fake or notional data sets, the SIMPUF data set. And you can just see, for example, that we have a column for person ID, which indicates, which person that particular row is about. Drug exposure ID, which is really just a unique identifier for every row in this particular table. Drug concept ID, this is the particular drug that that particular had encoded as a numeric identifier, and that's an important column right there. Then we have stuff like drug exposure start date, drug exposure end date, and then further on down in the table, we have stuff like drug concept name, which is the human readable version of the drug concept ID, which I'm showing right here. For the most part, we're not going to want to use drug names or the human readable versions of stuff. We want to use the concept IDs, and there's an important reason for that. The way that OMOP is designed is that it didn't, feel like they needed to create new terminology for medical terms. There are plenty out there. You've got ICD-9, ICD-10, SNOMED, so on and so forth. But what they did is they gave every vocabulary term from all of these different vocabularies an OMOP specific ID, and those are the concept IDs. So for example, ICD-10 J18.9, which is a code for pneumonia, is given the OMOP specific ID of 352079556. The original values, as we get them from our data partners, are kept, so you can always see like what the source information was, and then they're mapped into these OMOP specific IDs. The other thing that we do is, if you were to talk about something like pneumonia, there's sort of a standard way to code pneumonia in ICD-10. There's a standard way to code for pneumonia in SNOMED. There's a standard way to code for pneumonia in all these different vocabularies. And so what the OMOP folks decided is, hey, we don't need 10 different ways to talk about pneumonia. Let's just pick one and we'll call that the standard. And so basically what they do is a bunch of the concepts from some of the different vocabularies are considered standard concepts. And then other vocabularies are mapped to those standards. Most of the standards come from SNOMED or RxNorm, just because those particular vocabularies have a lot of good metadata in them. But that's not a hard and fast rule. So the idea is that, if our source data partner is using ICD-10 and they have pneumonia coded as J18.9, we sort of figure out the OMOP specific ID for that, and then we look up in a lookup table. There's a lookup table for this that says, okay, OMOP specific ID 3520796, which is the code for the ICD-10 code for pneumonia, isn't the standard. It maps to the standard of yada, yada, yada from SNOMED. So what you should see is in these drug exposure columns, you should only see in the drug concept ID columns, you should only see standard terms, not any non-standard terms. The benefit of having a much smaller set of standard terms for things is that they've also gone to the work of putting all this information into a hierarchy with information about how these terms relate to each other. So within the standard terms, you have information like Proquin XR, which has an OMOP specific ID of yada, 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 has an ingredient of ciprofloxacin, which also has an OMOP specific ID of yada, 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 yada. And that is an antibiotic, which has an OMOP specific ID of yada, 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 yada. So what you can do is you can use these standard concepts and their IDs, as well as this hierarchy information, which is included for the standards, to define what's known as a concept set. So if you wanted to say, hey, I need to identify everyone who took any kind of antibiotic, you could use this hierarchy to find all of the different OMOP concept IDs that refer to all the different kinds of antibiotics, and then match that concept set against the data itself to pull out all of the actual exposures to antibiotics. So this idea of a concept set, which is a set of these OMOP specific IDs, is very important in the OMOP design. And you should use it very heavily in your analysis. Especially avoid wherever possible going in and sort of doing text-based searches for ciprofloxacin or something like this, because of course not every human readable term has perfect information in it. So you don't have to generate these concept sets all by yourself, all by hand. Both Odyssey and N3C have developed some special tooling for working with these OMOP concept sets and OMOP data. There's one particular training module that I want to point you to, which is inside of the Enclave training portal. There's an intro to OMOP and contour training module, which works through an example analysis using OMOP data, as well as that contour tool that I talked about. Even though that's a graphical user interface, you can use it for doing this kind of data analysis on OMOP data. So we also have some specific N3C specific tools for working with OMOP data. I'm showing a screenshot here of the concept set browser. So one thing that you can do when you create a concept set inside of the Enclave is you create it as part of a pool of concept sets that everyone has created. And so you can actually go and browse through all the various concept sets that have been defined in the Enclave and see if someone's already created one that works for what you need. So for example, I'm showing your glucose concept set. You don't necessarily have to develop your own glucose concept set. You can search for it and use it inside of the concept set browser. Or you could create your own and upload it and then make it available for other people to use. You'll notice that we also have some buttons here for browse reviewed concept sets or browse different versions of concept sets. We try hard to develop good research practices, and so there's a review process that's been a long time in development, but it's finally coming to fruition so that experts, domain experts, can review concept sets and sort of validate that, yes, these include all of the stuff that you would want and none of the stuff that you wouldn't want for an analysis of this particular topic. A little bit more about OMOP, so definitely check out that Enclave training portal. There's the Book of Odyssey, which is a sort of a hybrid historical and technical overview of Odyssey and OMOP, which is really useful. Eden Academy has some longer form online training courses that you can watch videos of and so on and so forth. various Odyssey tutorials and things like that. And then specifically for the data dictionary on our covid.cd2h.org site, under one of the drop downs, there's a link for data dictionary, but it's really an ugly PDF. I rather like this particular data dictionary better. And again, I'll send a link to these slides in the chat so you guys all have them. But this is basically the OMOP publicly available data dictionary, which describes every table and all the columns that you would find in those tables and what would be in them. What it doesn't describe are some of the custom columns that we add for N3C that are specific to N3C needs, and we're going to talk about those in just a quick minute. All right, so that's OMOP, in general. But then, of course, there's OMOP as used by N3C, because we're taking this idea of OMOP as this common data model and putting it into practice. And what that means is that we're getting data from lots of different data partners and then harmonizing it into this one centralized OMOP database. But as we do so, we often find that there are lots of data quality issues that happen from our source data partners. Some sites have, data mixed in with other data where it shouldn't be. Some sites are missing particular data, like, oh, we noticed this particular data partner is missing all the creatinine measurements. And then, of course, there are stuff about units, right? Like some data partners measure things in micrograms per milliliter, and other data partners measure things in some other units. And so this stuff all needs to be harmonized together, as well as quality check to look for any errors. And so there is quite an involved quality check process. Wherein a team of experts who are familiar with these various things have gone in and looked at ways to harmonize the data and then sanity check them and do quality controls and visualizations and stuff. Another issue that we see when we're working with data from our data partners is that they're generally providing their data in these common data models, right? So they've already got data maybe in the PCORNet model, or they've already got data in the ACT model. Some of our data partners already have data in an OMOP model, and we're just sort of more like copying it over. But all of these different models support or require different information. And DEath is like a really good example of this. So data partners who are on a PCORNet model, in the PCORNet model, a date of death is not required in the record. On the other hand, in an Odyssey OMOP model, date of death is required. Similarly, there are other models where cause of death isn't even supported. So OMOP supports and requires listing a cause of death, whereas the ACT model doesn't even support listing a cause of death. So depending on which data partner we got the data from, you might find really systematic missingness of information in the tables, depending on what those particular data partners provide. And that's particularly true for death, I will say. So the death information is much sketchier than most other information. Additionally, because death requires more time just to be entered back into the electronic health record, unless the person happened to have died in the hospital. Couple other things to note. The definition of COVID itself is a little bit complicated because there are PCR tests, there are antigen tests, there are antibody tests, there are diagnosis codes, there are different ways of specifying, from our source data partners, how they encode the results of tests, whether you consider it present or high or elevated or something like that. And so we don't go in and sort of make an easy column that's like, is COVID positive in our data. Rather, we leave it up to the researcher to define their own definition of what COVID positive means for their research project. That said, we do have some resources that show you how to do this, and we have some shared definitions. We have code templates and concept sets that cover, we have a concept set for PCR and antigen tests and a separate concept set for all the different kinds of antibody tests and stuff like that. So it's not too difficult to define your own COVID positivity criteria, but we don't provide a universal one for everyone to use. This slide, I feel like I should pull just for time, but we did some time back a survey of folks and sort of like what information they're interested in from their research projects, and then a survey of our data partners to say, how easy is it for you to actually get this information? And sort of some information is really quite difficult to obtain. Death status is quite difficult to obtain, as we just talked about, but of course, it's also something that a lot of people consider very important when doing COVID research. ICU admission is another example of that. It's kind of difficult to obtain, but it's also important. We have other things that people identified as not so important, like family relationships. That's almost impossible, right? Because we have information about people, but we don't have linkages between people for re-identification purposes. So for example, there's a team who are working on pregnancy and outcomes of pregnancy. And while there are records about pregnant mothers and there are records about newborns, not very many of them, as I believe, we don't know who's a mother to which newborn because that would be a linkage that we can't allow from a patient privacy perspective. All right, so talking about all these different data partners and the fact that they are providing sort of different, slightly different input data, it can be very helpful to be able to disambiguate which data comes from which data partner. And as a result, what we include in every single table is a column for data partner ID, which indicates for that particular record, which data did that particular row come from, data partner did that particular row come from. And those are just encoded as pseudo-random numeric identifiers. So I can't tell you, for example, who data partner 732 is, but it's very easy to go in and facet your analysis out and break it out by data partner. That way, and you should probably do this, that way you can say, oh, look at these 8 data partners are all giving me more or less the same story in my results. But this particular data partner is showing me something completely different. I wonder why. And then you can go back and you can take a peek and you'd say, oh, I see this particular data partner is doing something different, or they're coming from the ACT model or something like that. We do have a list of known persistent issues that we are involved with N3C data. And once you have Enclave access, you can find them under this particular link. We're probably going to make it in a more obviously findable location soon, I hope. And there's something else to note that I've added recently, which is that some of our data partners pre-shift. So I mentioned that in the level 2 data, our data are randomly date shifted to protect patient privacy. Some of our data partners insist on doing this before they send their information to N3C. So we have some data partners who have date shifted information in the level 3 data. And you may want to filter those particular data partners out when you're doing your analysis. If you have level 3 access, because presumably you have level 3 access because you didn't want that particular date shifting going on. There's a table in the data set known as the manifest table, and that describes for every data partner which data model they're coming from, ACT or TriNetX or PCORNet, as well as if they already do any pre-date shifting. Data aren't always perfect. We do occasionally run into issues with the data. What's interesting is we have found some source data, and we've been able to get back to our data partners and say, hey, we found something wrong with your data that you didn't know about because we compared it to some other data partner and noticed some very big differences in trends. So we've gone back and actually corrected source data, which is a pretty cool thing that we can do with N3C that's more difficult to do in a different model. But we rely on our users to help us find issues in the data when they pop up. So if you see something strange in the data, oh, this data partner has nobody who ever got pneumonia, that's very strange, or whatever it is, do report an issue about it inside the Enclave. You can do that under the help and support link in the lower left, and then click on report an issue, and there's like a data quality option. Go ahead and flag it, and somebody will either say, yeah, we know about that, it's listed in the persistent issues, or they'll say, gosh, we didn't know about that, let us check with our data partner to figure out what's going on there. And there's a link at the bottom of this slide that you can't see. I guess it's not that important. I don't think it's supposed to be there. Okay. All right, I'm going to stop briefly for more questions.
Hello? Yes, I have some questions.
Yep, go for it. Go ahead.
Yeah, do you hear me, please?
Yep, I can hear you okay.
Okay, thank you. First question is about the accuracy of the data. My understanding is not all data partners provide accurate data. So for us to ensure that the data that we are accessing is accurate, uh, does Enclave uh, ensures that the data that we request is accurate? It is from partners that provide accurate data.
There's a there's a comprehensive quality check process that it happens when data is ingested from our data partners. Um, and of course, we request our data partners alert us to anything that they're aware of. There's a table which describes if they pre-shift dates or anything like that. I don't know that we can make guarantees, however, because data errors can happen anywhere from the pipeline all the way down to when the medical assistant is typing the record into the system in Epic or wherever it is, at the patient visit, all the way up to systematic errors that we've discovered about, a mapping problem at a data partner where they had simply an error in their pipeline where of their data warehouse. So we certainly look for any issues that we can find, but I think it would be irresponsible to make any guarantees of data accuracy.
Another question is about the data that is prohibited or restricted by Enclave. In case that the research institution is interested in part of such data, is it possible that the request can be approved, or it is completely prohibited and not allowed for the research institution to get access to such data?
Oh, I only got like every third word of that. Can you repeat it?
Yes, please. When we are interested in part of the restricted data, is it possible that to have access to such a part, or it is completely restricted? We cannot get access to the data.
I'll ask if anyone else managed to parse that out. There's really a lot of background noise.
I'm sorry, did you hear me?
There's a lot of background noise. I'm having trouble hearing anything.
Yeah, I'm sorry. So I was asking about.
Feel free to look us up or submit a ticket, and we're happy to answer any question online as well. If you can go to our main website, there's a support section, and if you ask a question there under the support section of the website, covid.cd2h.org, there's like a 24-hour turnaround time on that particular help desk.
Okay, all right.
That's probably it. And then you can get your questions answered that way pretty efficiently.
Okay, thank you.
Sorry. Anybody else? All right, then we'll move on to the last segment of our little presentation here. So we've talked an awful lot about the data so far, but I want to spend a little bit of time talking about N3C, our community. We're obviously a lot more than just data. We're a big a community, and we're a big community. So this slide, I think I really need to update it because it's been a couple of months since I have, but we've got over 2,200 registered users. Over 1,300 folks have access to the Enclave, and there are over 160 ongoing research projects affiliated with data use requests. There are probably well over 200 institutions now with data usage agreements, so that everyone at those institutions can get access to the Enclave without too much trouble. And I think right now we're up to about 65 data partners who have data inside of the Enclave, but there are over 85 data partners who've signed the agreement to transfer their data over. So we're still waiting for some more data to show up, and our database will continue to grow beyond the 6 or 7 billion rows that we have right now. Um, Communication is a big thing in N3C. So our Slack organization at cd2h.slack.com is quite active. It's also a good place to sort of chat about analysis strategies and stuff like that, provided you don't upload any patient sensitive information or screenshots or anything like that. That's a great way to talk about tips and tricks, and meet with other folks. Google Groups and the Google Suite is used pretty heavily. A lot of teams use Google for their own internal communications, mailing lists, and so on and so forth. And of course, we have lots of meetings. So in case you didn't already have enough meetings on your calendar, we've got 20 or more weekly meetings that you can add. And you can check those out at covid.cd2h.org/N3C calendar. So, N3C is like a big virtual organization, and I think that it helps to have a little bit of a mental map of what that organization looks like. This is my mental map of what that organization looks like. It's unofficial, it's not been produced by anybody in like any of the PIs or anything like that. So I'm just kind of giving it to you as my own benefit. But when we first started N3C, we kind of thought that there were going to be like 5 important work streams. So data partnership and governance would be a work stream, synthetic data, because that was going to be its own thing as a work stream. Collaborative analytics is the work stream where we sort of put on all the actual research underneath of it. Phenotype and data acquisition, those are the folks who work with our data partners. And then data ingestion and harmonization, those are the folks who sort of get the data into shape to be analyzed. And so those are the main work streams. And of course, there are teams under these various different work streams. So under the data partnership and governance, you got like the publications committee. They're sort of like reviewing proposed publications, make sure they match the GURs. We have a wonderful project management and administration team who I hang out with a fair amount. And then under the synthetic data work stream, there's that synthetic validation team who I mentioned. They're sort of asking the question, okay, are the synthetic data generating good results compared to the real data? And then under collaborative analytics, that's where we put, or at least in my head, where we put all the research projects. And so this is a hypothetical research project that I'm showing here, heart disease and COVID-19. Maybe some team from some place is interested in studying heart disease as it relates to COVID-19. And so their research project will live underneath of this collaborative analytics work stream in my mental model. But what also lives under the collaborative analytics work stream in N3C are what are known as domain teams. And domain teams are sort of like a higher level topic organization of research projects. So for example, there's a domain team that's focused on diabetes and obesity. And there's a domain team that's focused on immunosuppressed or immunocompromised patients. And then a particular domain team might actually have multiple research projects underneath of it, right? So the immunosuppressed, immunocompromised domain team has a research project looking at COVID and HIV. And they also have a research project looking at autoimmune skin disorders and things of that nature. So these are sort of like higher level teams to help bring research projects closer to each other so that the people who are working on HIV and have figured out the right kind of concept set for looking at COVID can share that with their colleagues who are studying autoimmune skin disorders. And so this is a really great way to get involved and to meet other people who are interested in related research as you. And the domain teams also have a domain team lead, and those are the folks who help with communication and coordination and stuff like that. So those are our clinical domain teams, mostly focused on, sort of like the patient level results. We also have what are known as cross-cutting domain teams, and these tend to be focused more on like methodological things. So we have a machine learning domain team who might be looking at multiple projects around machine learning in N3C. I think there's a genomics domain team, though I don't know what they're up to right now because I don't think we have any genomics data, who are looking at options for linking electronic health records to genomics information. And the hope here is that the various folks in the machine learning domain team can spread their knowledge about machine learning to the other projects and other domain teams in N3C. Additionally, what we have out of the phenotype and data acquisition and data ingestion and harmonization work streams, we have what are known as data liaisons. These are a set of folks who do the work of phenotype and data acquisition. So they work closely with our data partners, and they also do the work of ingesting and harmonizing all the data together. And they make themselves available for consultation to researchers so that if you have a question about the data, and it's really a deep kind of question that can only be asked or answered by somebody who knows the data really well, then the data liaisons are that service that we provide. However, they're really one of our most precious resources. There's only a few of them and their time is limited. So rather than the data liaisons sort of being available, making themselves available for consult to everyone, they focus mostly on the domain teams. So every domain team has a data liaison sort of associated or assigned to it. So the immunocompromised, the immunosuppressed domain team has a data liaison who works with them and shows up to their meetings and answers questions. So there's a reason to, if you have a research project, get linked up with a domain team, because then you get access to some of these extra N3C level supports, as opposed to my hypothetical research project here, heart disease and COVID-19, who didn't affiliate with a domain team and are sort of going it alone. Domain teams also get a little bit of extra administrative support for things like calendaring and meeting scheduling and so on and so forth. All right, so that's the end of our presentation. I'm exactly at my 1.5 hours. Went a little bit longer than usual today, but I think that's okay because we said it would be an hour and a half. If you're not sure where to go next, definitely check out the various resources that we discussed today. Get registered if you're not already registered. Start that process of getting access to the enclave. Do check out the N3C website, especially the domain teams section of the website, because those are really great resources. If you're not sure where to start, contact the domain team lead. They're all really great people who sort of have taken it upon themselves to do organization and get people onboarded and hooked in, and meet with some people who are already doing research similar to what you're interested in. Access the enclave and browse around, especially those training resources and the training portal. And then, as I mentioned, in 2 weeks, come back for orientation session B, where a colleague of mine, Saad, will introduce some of the actual analysis techniques and tools for working with the N3C data specifically, since we do have so many things that are not a little bit novel to folks, like OMOP or the N3C specific modifications or additions that we've added to OMOP. Okay, B. Jameson asks, how can we obtain a link to this recording? Somehow there's a way for me to email all of the attendees, and I will try and figure out how to do that and send the link to the recording, as well as maybe a link to an evaluation form so you guys can evaluate me and my quality here. Yeah, I'll figure out how to send you guys an email, but let me also, before I stop, send a link to the slides in the chat. I also wanted to briefly mention, so if you go to covid.cd2h.org/tutorials, this is going to be re-architected pretty significantly before too long, but there are recordings of the session A and session B orientations from previous runs. So even if for whatever reason I'm not able to email you guys out a direct link to this particular recording, this particular orientation was previously recorded from a previous run, and you can go and view it right on YouTube. Links from the covid.cd2h.org/tutorials, which I think is under the resources dropdown. Oops. Alrighty. Any final questions? Thank you all for showing up, and thank you guys for participating in N3C. I think it's like a really cool silver lining of the COVID cloud in terms of the model and the research that we're doing. Okay, well, with that said, I'll be hanging out here for just a minute, and then I'll stop the recording, or I'll stop the meeting. I'll stop the recording right now. If you guys have any more questions, feel free to say hi. Otherwise, I'll see you in the enclave.